A century ago, black holes existed only in equations, pure math, no proof. Today, we photographed one. But hiding in that same math is something even stranger, a black hole's mirror opposite. Physicists call it a white hole. Picture a black hole on video, pulling in everything nearby, gas, light, matter, never letting anything escape. Now play that footage backwards, matter flying outward, nothing able to fall in. That reversed video is a rough picture of what a white hole would be. Here's a simple way to feel it. Watch water drain from a sink. That pull is like a black hole. Now imagine a jet of water bursting upward out of the drain instead, impossible to push back down. That outward burst is the white hole idea. Black holes have an escape velocity higher than the speed of light. That's why nothing gets out. A white hole would have the reverse problem. Nothing could get in. Light and matter couldn't approach it at all, because its gravity would function as pure repulsion at the boundary. And that raises an obvious problem. White holes still have mass. Anything with mass should pull things toward it with gravity, the same way the sun holds planets in orbit. So how can something have mass yet repel everything at its surface? This is exactly why most physicists think white holes probably can't exist in the real universe. The physics doesn't hang together cleanly. It's important to be clear here. White holes are not a proven or observed phenomenon. They're a valid solution to Einstein's equations, but a solution isn't the same as a discovery. If white holes exist, ancient ones formed near the birth of the universe could be extremely small, even microscopic, making them invisible and hard to detect, which has led a small number of researchers to speculate they could be linked to dark matter. This is a fringe hypothesis, not a mainstream explanation for dark matter, which most physicists attribute to other causes entirely. An even bigger and more speculative idea, some have compared the Big Bang itself to a white hole, a single point suddenly expanding outward into everything that exists today. It's a poetic comparison, but not something cosmologists treat as an established model of the Big Bang. In 2006, a NASA satellite detected an unusually long gamma-ray burst, GRB 060614, lasting about 90 seconds, far longer than typical bursts and not matching the usual signatures of a supernova or a neutron star merger. It remains a genuinely puzzling event. A tiny number of physicists have floated white hole as one possible explanation, but the mainstream view is that it's more likely an unusual variant of known burst mechanisms, an alternate supernova process, not evidence of a white hole. The honest answer? White holes are almost certainly a mathematical curiosity rather than something waiting to be discovered, an artifact of what happens when you run the equations of gravity in reverse. Most physicists believe they're theoretically valid, but physically unstable or impossible. Still, 50 years ago, black holes were just math too, until we found one. Whether white holes ever cross that same bridge from equation to observation is anyone's guess.